So, questions. Was there anything I could help you with on the 6-2, the 1 through 9 odd? Do you feel comfortable with it? You're okay that the null has some sort of presence of the word no? No or not or or not this time or something like that? Do you feel comfortable? I just want to make sure you feel comfortable with the one tail versus the two tail test. One tail is you definitely have a direction, so that has to go with global warming. Means we're getting warmer, so we're going one way, getting warmer. Whereas a climate change, that could go either way.
So it's going to be like a conceptual question.
Yeah, it's just something to think about. Is there a direction I'm going, or does this? Are we hoping this is here, or could it be out here? Versus if it was global warming, let me see if I do this right. I'm going to do it for a second for you guys. Global warming would be this way. Climate change would be these things could take place. Okay, so that's the ins and outs of this. So you feel comfortable with that homework? It seemed good. You know, that was the longest page-wise assignment I think we've had all year, just because you have to write. Yeah, like, dude. And then I love the fact that on page 96, intentionally blank.
Yeah, you should think.
That was Mr. Anderson all day long. So, all right. So let's take a look at 6.3. This starts talking about something called the p-value. Now, so all of the tables that we've done, whether it was using the calculator or I gave you a table, long ago when this guy was taking statistics, we had an actual book. It was like our book. If this book was up there, 25 years ago, 30 years ago, the very back pages of the book would have different tables in it. And a p-value is something that would be at a table and deals with degrees of freedom. You have all of these things that would fall in. You'd have to go to the back of the book and figure out which table you're referencing in order to get your information, because we just didn't have the technology at the time to do it. Okay, so this is 6.3. I'm on page 25 of this semester's book. Okay, and then we're going to be talking about something called the p-value. Okay, and this is something that we use where we start, well, as we go through this lesson and probably through tomorrow's lesson, or if it's starting tomorrow, then the following day's lesson, talking about what the p-value really does. Now, all right, I'm not going to be mean, because I have up on our board that we go with 6.1, 6.2, 6.3, 6.4, and then review on Friday. I would probably do 6.5 on Monday, and then on Tuesday we would do, I think it's just 6.1 to 6.3 quiz. It's a front and a back. It's not too bad. Obviously, no cards are in effect, but I didn't want to do it on Monday. Monday's just mean to do, right? Oh, wait, we don't have school Monday, nor Tuesday, do we? So I will not give you the quiz on Wednesday. Okay, so that helps me out. So Wednesday next week, we will just kind of continue our review because it's a shorter period, and then Thursday next week we will do the quiz, and then Friday do 6.5. Sound like a deal?
Yes, sure. So we have the advisory schedule next Monday still?
Yes.
Why?
I don't make. I'm not in a decision-making place to do that. I'm sorry. All right, so ready, set. What's up, officials? Doing well. It's a 74% chance of a snow day. Gotcha, Gio. All right, so ready? Page 25. Everyone's good? We're happy? So when using regions, shaded areas in our questions. So again, the shaded regions become, any of the particular. This would be a two-tailed shaded region because we have both sides. There's obviously a z-value or a standard deviation or a t-score or something like that that falls somewhere on that. So when we use regions, shaded areas in our questions of normal distributions to calculate probability in a way, we are answering a really basic question. What is the probability of a specific set of results occurring by random chance? Okay? So you're asking, what is the probability that something could randomly happen? What's up, Manuel? You need me to sign that off for you? Yeah, buddy. How are you today? Y'all know Emmanuel? He's one of my faves. One of my fave freshmen. He's a good guy. Good guy. He's a sophomore, sorry. Didn't mean to make it too young. He's a great kid. He's an absolute pleasure to have in class. I love him.
Yeah, but I had to talk to like other people. Like he just like talks to people who are like walking past him and they just walk
Maybe
past
he's a
him.
friendly person.
He is.
Like, no.
All right.
That's his version of being.
So, as we collect data and evaluate the statistical evidence, we need to know the likelihood that a random chance explains the results of the study. If a random chance is reasonable or likely explanation, then our evidence is weak. Okay, an example. Let's say we have a new medication for lowering cholesterol. So it's lowering one or two tail. One, lowering is the direction. We want to know if the medication is actually working. We want to know the average cholesterol level nationwide, and they tell us it's 180. Will our new medication bring this level down? Okay, so obviously we're not going to give the entire nation this medication because one, it's way too much, but two, it's we can also do samples of people randomly and determine it. Okay, so they're saying let's say that we have a random sample of 100 people that take this new medication and obtain an average cholesterol level of 178 with standard deviation 15. Okay, so we knew that our entire population, from some medical information, tells us that nationwide we have an average of this. Okay, so that's our population. But we have a sample, a random sample of 100 people. And then we find that they have 178 cholesterol level by taking this medication. But then they say that we have this standard deviation. So this is our sample. We'll call this our sample mean. But then we realize we have a standard deviation of our sample of 15. Okay? So the standard deviation is the key to this. And here's the unfortunate thing. As far as anything goes when looking at statistics, you all have been part of some sort of educational experiment, we will call. And as a teacher, I have seen, I'm going to call them gimmicks, come and go very often throughout my entire career. Okay? And I'm not saying that it is a bad thing, because it's always kind of interesting saying, hey, this might be something. Now, and I know I talked about this before, but I had done that when I was the math science coach for the district for Career Tech Ed and also STEM. Smoky Hill High School's business department came to me and said, hey, we want to show that kids that take our business classes at Smoky Hill High School do better on the ACT than the rest of the school. Okay? Like, is there something happening in a business course that is allowing a student to do better on a test? And because, I kid you not. So my job originally when I came here, I would teach my medical class here and the medical class here, because school started earlier, used to go from 6 to 7 o'clock in the morning. Okay? And people were like, no one will come. Yeah, I had 126 kids at my very first time I taught the class here. So they came. And then I taught first period college algebra and the statistics, one semester statistics class we offered. And then the rest of my day, so basically from about 8:30 on, I would go to all these schools. I had a lot of time. I had a lot of times I'd be sitting in my office and I was crunching data and looking at the statistics of the data and finding if there was validity in what certain places were doing. So Smoky Hill said, we're going to use Chris Stirrup. This is going to be fantastic. And what I did is Smoky Hill's business department said, yeah, let's try and get the 34 to 35. It's like, okay, well, that's pretty tough, because if you're getting a 34 versus a 35 on the ACT, you're talking about like 95% of the population scoring, you'd have 5% of your population probably scoring the 95, probably about 3% scoring, the 1 point higher. So it was a small thing. So I told him, I said, really what we should do is let's focus on 5 types of questions on the ACT. Let's focus on a hard one that's a medium hard, one that's a medium, one that's a little bit less hard, and then a real simple one. And they're like, why are you worried about that? I'm like, because if you can get the kid to go from an 8 to an 11, that's a far more larger growth for your average score than taking a kid to go from a 34 to a 35. And they're like, okay, sounds good. And so I had some really strange permissions that were given to me as a teacher on special assignment, that I was able to get all of Smoky Hill High School's ACT scores for the year prior. Then I started this prescription with them and had the data for that current year. And then the following year, we put the prescription in place where the business class gave this 5 questions to the kids as a pretest. And then there was 5 videos that the kids could watch that I made that taught them how to do those questions. Then they would give the kids the 5 questions again. And then, if the kids didn't get all 5 correct, then they would watch my videos again and prepare a little bit more. And then they get that 5 questions again. And basically our goal was to try and get the kids to get 4 or 5 of those questions right, regardless of how well they would have been doing in school. Well, here was the problem. I was able to say, hey, look, we had a better score than what it had been for the business classes. And they're like, great, it worked. But the standard deviation was something like this. So look at the standard deviation. If I go 1 standard deviation, whoa, turn back on. Go. Hey, what are you doing? What happened? Oh boy, can't have nice things anymore. So what happened was the standard deviation is kind of your tell-all if something happened by coincidence or something happened on purpose. And being that the standard deviation included the score of the entire school, that was pretty vital. And they were like, hey, look, we showed we had a better average. And it's like, no, but your standard deviation is too wide. And they're like, well, what's that? And the standard deviation, I mean, think about like just what a normal curve of this would look like. If we took our sample information, we said 178, and we went plus 15 this way and minus 15 this way, this should encompass 68% of the population as far as a normal curve. Okay? Now the problem is this 180 falls right here. Okay, so it's within the standard deviation. So was it coincidental that they had randomly sampled 100 people that had already had this better cholesterol? If they did the test again, they might get another average. They might get another standard deviation. And as we go further and further and further, those are things that you kind of have to keep into as category. And what I had to tell Smoky Hill High School is basically you're wasting your time. If we do this, we're wasting time. I mean, it's okay that we're putting a prescription in place to try and get a different result, but is it really working? And I had to tell them that it wasn't. And they were so saddened by it because they were so excited that, if there was a cholesterol test, they would have been excited saying, hey, look, our kids are taking, if I was testing the cholesterol of kids, which I wasn't, but, hey, the normal population is 180, but hey, we got 178. So kids obviously take our business class, have a lower cholesterol level. No, you can't say that with certainty. It just happened by a coincidence. Okay? So intuitively, the difference feels very small. Random sampling variation will produce different results for different samples. The difference of 2 doesn't seem very impressive. Can random chance be the explanation behind the difference? It's a question we will explore, a little more deeply. Okay, if the group receiving the medication had produced an average cholesterol level of 170, the evidence would be stronger. So if this resulted in the 170, it would be a stronger idea. But still, if I did a normal curve based off this, we'd go 170 plus 15 minus 15 to get the 68 population. But the thing is, you still have the 180 that's falling into this region. Okay, so it could signify stronger evidence, but it's still not 100%. Okay, how do we know that the difference is great enough to represent strong statistical evidence? As with many things in statistics, it's hard to make judgment calls. It's even harder to make judgment calls when they have a vested interest in the outcome of our research. Therefore, we need an impartial statistic to help us in measuring the quality of our statistical evidence, and they're going to call that the p-value. Okay? So the p-value is just a tool to start measuring, hey, is this going to happen again? Did this happen by accident or did it not? Okay, and the p-value is going to certain value, and we're going to find out what a p-value means in a minute. So as informally, the p-value is the probability of obtaining a result at least as unlikely as the one we obtained by random chance. So this is basically a probability that it should happen again. Okay, and p-scores can be really small decimal numbers, and they could range anywhere. Okay, so a simple example from the recent unit probability. Let's say we have a new technique for flipping coins that produces the result of heads more than 50% of the time. To my method, I flip a coin 10 times and I get 9 heads. That's great, but maybe that was just blind luck. Okay, what is the probability that the result at least as unlikely may occur? Well, it takes out a return probability of getting 9 out of 10. 9 or 10 heads on 10 flips is approximately 1%. Therefore, the p-value is 0.01. So if you had a percent come out, your p-score is the decimal of that. So that's pretty low. Okay, low p-values result when we obtain a sample that is very unlikely to have occurred by random chance. Therefore, low p-values produce stronger evidence against the null hypothesis. Remember, the null is the one that says no or not or something like that. In statistical research, I'm on page 26 now. This plays out differently. Let's say we are conducting research into whether consuming large amounts of sugar lead to insomnia, which is sleep difficulty. Okay, our hypothesis is sugar consumption does not produce insomnia. Okay, and our alternative hypothesis, sugar consumption increases the risk of insomnia. If our p-value is low, then we reject the null hypothesis and find strong evidence that sugar consumption increases the risk of insomnia. If our p-value is higher, we fail to reject, again, we're using the weird double negative stuff, the null hypothesis, and fail to find strong evidence that sugar consumption increases the risk of insomnia. The p-value itself is a proportion or a percentage. It represents the probability of obtaining the result that are as least different from the null hypothesis as the one that we obtained in our study above. Let's assume that the data produces a p-value of 0.13 or 13%. That can be interpreted as follows. If sugar consumption does not produce insomnia, the probability of obtaining an increase in insomnia at least as great as the one our study obtained by chance is 13%. So informally, our results, like ours, could be obtained by random chance of 13% of the time. That's pretty low, but is it low enough to reject the null? And it's something that we will debate. So rule of thumb is this. If the p-value falls below 5%, So if the p-value is less than 5%, then we often reject the null. Okay, that's the hypothesis that has the word no or not or something like that. Why 5%? So this is something that we will find later. But do you remember when I was telling you about the Algebra 1 class that me and one of the other teachers was teaching? We'd have 60 kids in a double-wide classroom. So we based our findings on a test that you all opted out of, but we did it off of the state assessment. And we did a two-tail test, okay, because we wanted to show that there was better results by teaching the two of us in a class of twice as many kids versus a single teacher teaching just 30 kids, or whatever the number of kids was of half the size. And we actually came up with a score of like 0.0821. So it was an 8% chance. Okay? So was it good? Was it bad? Well, we could have fudged the data to make it better for us. It was kind of enjoyable knowing that, you know, if I said something in class, there was a second teacher that heard it, or vice versa. So, you know, we've all heard, we all know, and I know as me as a teacher, I've said the wrong thing, and you can take a fragment of anything I say, and it really seems like a really bad thing I said. And unfortunately, that's where a lot of things come into play, you know, just in everyday life. Hey, you said this. That was a fragment of what I said. Yeah, but you said it. So many years ago, when I was an assistant principal for 5 months, okay, and then I went back into the classroom. I was the guy who was in charge of suspending kids. And I was taught at an inner city gang school, so my office was busy because I had kids all the time that were in the office because they got in fights. They were tagging stuff. They were destroying school property. They were doing all kinds of silly stuff. And I had a kid, I still remember this kid to this day, Erasmo de la Fuente. Any of you related to Erasmo? Good.
Erasmo's my boy.
Yeah. Erasmo, and it was a little frustrating because you have some teachers that keep the dean's office busy with silliness, and then you have some teachers that handle quite a bit of stuff in-house before they actually turn to the administration. Well, Erasmo was sent up by Christy Eason, his math teacher, because for the 5th day in a row, Erasmo didn't have a pencil. Okay? I kid you not. Now, realize this. I got 2 kids sitting in my office that just beat the living daylights out of each other. Another kid that's sitting in my office in handcuffs because he got caught with green leafy substance that he shouldn't have had on him. And then I have Erasmo who hadn't brought a pencil now for the 5th day in a row. So you know, Erasmo is at the top of my list.
After he got let off, Erasmo.
So my conversation with Erasmo basically starts off with this. Hey, Erasmo, do me a favor. Each and every morning or any period you want, come to my office and I will give you a pencil and you can keep it. Erasmo didn't like that. Huh? Yes, please. So I think this is a fine solution for Erasmo, and it seems good. No, Erasmo decides to take it to the next level and start screaming and yelling at me. Meanwhile, I have one of the school police officers in my office because he's trying to figure out if it's okay to take the kid that's in handcuffs away, or do I have anything left to do? Oh, thank you so much. Look at that. So Erasmo starts just going ballistic. He starts screaming at me, he starts screaming at the cop, starts punching the walls. And I'm just sitting there looking at this kid going, I offered a pretty darn good solution for this kid, I think. Being that the buses that he rides to school drops off right outside my office, he just needs to walk in the door and say, hey, can I get a pencil? Boom, he got a pencil. My secretary's out there. She's got, boxes of pencils. Pencil's not a big deal. But he didn't like this idea. He wanted to tell me how much that this female teacher reminded him of a female dog, derogatory term. And I'm just sitting there watching him, and I'm thinking, what in the heck did I say? And so I'm like, Erasmo, calm down. And I make this statement, and I don't deny that I didn't say it. But my statement is, Erasmo, and I can't remember my exact words, but I remember the exact statement. I said, Erasmo, and this is paraphrasing, if you continue with this type of behavior nonstop throughout your life, you're not going to amount to anything. Okay?
It's a great thing to tell a student.
So it's I'm just trying to get him to cool his jets. Well, this statement is wheedled down to this.
Yep.
Now I got grandma and uncle has been in prison many times. He's got some tattoos that are fancy looking things on his neck, on his eyebrows, his face. And I'm just like, okay, are you sure you're talking about that? I was like, dude.
No.
So I'm trying to backpedal. No sense of it. Like, you see this hole in my wall here? And you see that hole right there? Yeah. That was Erasmo. It doesn't matter. So that was actually the point where I realized Stirp doesn't want to be an assistant principal anymore. And I knew that I had a teacher in my building who was going to resign at semester because she was pregnant and going to have her first child and wasn't going to come back to teaching. So I applied for that position, went back in the classroom, said, whew, I'm out of that. So I was happy about that. But I don't know why I got to that point. But do you guys want a lot of homework tonight? Come on, will it ever be yes?
So if I got work though.
Okay. Well, if we have a snow day tomorrow, we have plenty of time. So page 97, 98, what do we say? We look at 1 through 9 odd. Good enough?
I'm about to